Hello, and welcome to the section Other Popular AWS Services. In this video, we will talk about SQS, the simple queue service provided by AWS. Let's first have an overview of what is message queue and its benefits. So basically, message queues are used for communication and coordination between distributed applications or services. It can significantly simplify coding of decoupled applications, while improving performance, reliability, and scalability. Message queues are different parts of system to communicate and process operating asynchronously. There are many benefits of using message queues in our cloud applications. The first is decoupling. Message queues are an elegant, simple way to decouple distributed system. Whether you are using monolithic applications, microservices, or serverless architecture. Redundancy is one of the most obvious advantages to message queues. Queues help with redundancy by making the process that reads the message confirm that it complete the transaction and it is safe to remove it. If anything fails, worst case scenario, the message is persisted to storage somewhere and won't be lost. It can be reprocessed later. Queues can be great in scenarios where your application needs something done but doesn't need it done now, or doesn't even care about the result. Some people call this fire and forgot pattern. So instead of calling a web service and waiting for complete, you can write a message to the queue and let the same business logic happen later. So queues are an excellent way to implement an asynchronous programming pattern. The next is granular scalability. Message queues make it possible to scale precisely and independently. Where workloads peak, multiple instances of your application can all add requests to the queue without the risk of collision. As your requests get longer with these incoming requests, you can distribute the workload across a fleet of consumers, producers, consumers, and the queue itself can all grow and shrink on demand. Message queues are very reliable. It makes your data persistent and reduces the errors that happen when different parts of your system go offline. By separating different components with message queues, you create more fault tolerance. If one part of the system is ever unreachable, the other can still continue to interact with the queue. The queue itself can also be mirrored for even more availability. And finally, the performance. Message queues enable asynchronous communication, which means that the endpoints are producing and consuming messages interact with the queue, not each other. Producers can add requests to the queue without waiting for them to be processed. Consumers process messages only when they are available. No component in the system is ever stored, waiting for another, optimizing the entire data flow. So now let's take a look at the AWS SQS. Basically, SQS provides two kinds of queues. The first is called standard queue, and the next is called FIFO, or first in, first out queue. The standard queue has literally unlimited throughput. It supports nearly hundreds of thousands of transactions per second per API action. And the standard queue provides at least once delivery. A message is delivered at least once, but occasionally, due to the nature of cloud computing, it can be delivered more than one time. The standard queue will try best effort of ordering. Occasionally, messages might be delivered in order different from which they were sent. So now let's take a look at the first in, first out queue. First of all, this queue provides pretty high throughput. It supports up to 300 messages per second when you batch 10 messages per operation. FIFO queues can support up to 300 messages per second. To request the increase limit, fire a support request. And obviously, the order in the FIFO queue are sent and received in its strictly preserved. As a comparison to standard queue, the FIFO queue has exactly once processing. That means a message is delivered once and remains available until a consumer processes and deletes it. Duplicates are not introduced into the FIFO queue. So, as a conclusion, the standard queue is very good for sending data between applications where the throughput is important. For example, allowing tasks to multiple worker nodes, process a high number of credit card validation requests, etc. And FIFO queue is very good for sending data between applications where the order of events is important. For example, whenever we need to ensure user-entered commands are executed in the right order. Okay, so now let's have a hands-on demo on SQS. I'm at this Simple Queue Services landing page. Let's go ahead and get started. So in this queue name, we can give it, say, my test queue. And we will choose this standard queue type as demonstration purpose. And we would like to configure the queue so that we can look into the detailed configuration. Okay, so there are a few configuration items we should pay attention. The first one is this called default visibility timeout. So to explain, this is a mechanism provided by SQS in order to prevent other consumers from processing the message again. SQS set this visibility timeout, which default to 30 seconds. We can set to 0 seconds at minimum or 12 hours as maximum. During this period of time, SQS prevents other consuming components from receiving and processing the message. If the message that isn't deleted or message whose visibility isn't extended before the visibility timeout, Express counts as a failed receive. Depends on the configuration of the queue, the message might be sent to dead letter queue. Please note that visibility timeout can be overridden at a concrete message level. The next thing is this called message retention period. So this simply means the amount of time that SQS will retain a message if it does not get deleted. Let's go ahead and create this queue. Alright, now we have this my test queue created. We can see how many actions we can perform for this queue. We can send a message, view or delete messages, we can reconfigure the queue parameters, and we can purge or even delete the queue. We can also subscribe the queue to SNS topic. That means whenever we receive a message in the queue, we can configure to receive an email or SMS notifications in SNS. And finally, we can click this trigger for Lambda functions. That means you can imagine upon receiving a message, we can initiate a workflow or perform some task running in Lambda. So it is really powerful yet convenient. So now let's try out by sending a message to this queue. In this send message dialog, we just type some random message. We can also choose to delay. For example, I just want to delay 2 seconds. In the message attribute, we can specify the type of this SQS message. So let's skip this for now and we go ahead and send this message. Alright, so we saw this message has been sent and it noted that take up to 6 seconds for the message delayed attribute to update, and we actually set that to 2 seconds. On the other hand, we can use a programmatic way to receive messages for this particular queue. So as we can see that the queue has a unique URL printed here. Let's copy this. And here is a simple snippet of code written in Python to listen to this particular queue indefinitely. So at the beginning, we can copy the URL of our SQS queue URL here. And we can simply say we initiate a Boto3 SQS client, and we invoke the standard API, say receive message, and specifying those parameters. And this part we're just interpreting into the message, and we'll print whenever we receive a message. And as soon as we received this message, we'll invoke this delete message API by passing the received handle we interpreted above, and we will print out, say, message deleted. Okay, let's give this script a try. So as we can see, we received this message, And this message was exactly the one we sent just now in the AWS console. And as soon as we receive this, we delete this message. So now if we go back to our SQS AWS console, and we click this View Delete Message again, we start polling, we won't be seeing that message we just sent again because it has been deleted programmatically. Alright, with this, we completed this video.